Hello and welcome to today's Infosecurity Magazine webinar. My name's Dan Raywood, I'm the contributing editor of Infosecurity Magazine, and I'll be moderating today's event in association with Salt Security. And so for the next hour, we're going to be looking at API securities, how to manage attacks, vulnerabilities, and complexities in APIs. And as I've just been chatting offline to one of our speakers today, I'm a bit of a novice when it comes to kind of API security. I know a little bit about AppSec, obviously some of the stuff we've done here on Infosecurity. So expect some of my questions to be a little basic. So if you are keen to ask more technical questions, we have the expertise today. If you're a bit like at my level, hopefully you're going to sort of resonate with what I'm going to be asking, because I've seen a few stories around the past. We were discussing one just before from about 4.5 years ago. But we're going to be taking a bit of a broad view of API security today on this webinar. So before I do pass you over and introduce you to some of the speakers today, a few housekeeping points from me. We are going to have some polls running throughout the hour, so please do join in with those as and when they appear. If you have any questions, then do ask them. I'm going to be asking a few. I'm certainly going to be kind of I might even start with what does API stand for, but I wouldn't be that daft, would I, really? So any questions today, do use the questions function just below the main screen. And if you have a question for a specific presenter, obviously we'll do our best to try and delegate that to the right person. If you're on Twitter, hashtag InfosecWebinar. We've been tweeting a little bit promoting this webinar, so anything you want to talk about, we'll try and share a few thoughts as well via social media. And also, if you're a member of ISC2, ISARC or EC Council, you can claim 1 CPE credit based on a minimum attendance of 50 minutes, 50 minutes. So if you're just joining now and we're a couple of minutes in already and you feel like you're missing, don't worry. All you've got to do is do another sort of 50 minutes, and obviously do stick around to the end and you'll get that credit. You can download those from your Infosecurity account. Sometimes it can take like 48 hours to be processed, especially if you're listening on demand. So do give it a little bit of chance to and catch up, so we will be able to do that. Right. Let's move on and introduce our speakers today. So I'm Dan Raywood from Infosecurity Magazine. Delighted to be joined by James Jardine. He is CEO of Jardine Software, and also Roey Eliyahu, who is CEO and co-founder of Salt Security. So big thanks to James and to Roey for joining us today. And so we'll be hearing from both of those in a couple of presentations we have got coming up. But before we do that, let's launch our first poll question. Well, I'll text for you today, but how does API security rank in your list of security priorities? So I'm going to read these slowly, conscious of how far to get. I talk when I get excited. But anyway, how does it rank in your list of priorities? Is it top priority? We're actively evaluating solutions. High priority, we're starting to gather details and talk to vendors. Medium, we're currently gathering details about solutions. Low priority, gathering details for my own education. Or finally, we already have a solution for API security. Maybe you've just done a little bit ahead of the game there and you've already got something. Apologies for that, everybody. My line just got cut off, so I hope you got a bit more time to vote. So anyway, it was in the middle of me talking. I had finished, and so do please vote on that. I don't know what that was, but big thanks for who have voted so far. Right, let's push on and introduce our first speaker today, and I'm going to figure out what's wrong with my phone, and that is James Jardine, who is CEO of Jardine Software. So James, I am going to hand over to you.
All right, thanks, Dan. I'm sure you were just dipping off there real quick just to look up what API stood for, and that's all right. For those that don't know, it's an application programming interface, and we're going to talk about that today and talk about some of the complexities that exist with these different interfaces. And don't worry, if it is something that you're not sure about or you have no experience with, that's fine. I know Dan said he might ask some very basic questions. What is basic to some may be complex to others. So feel free, if you have questions, to ask them. Happy to answer them. And our goal here is to talk about the complexities with APIs, and we'll talk a little bit about some of the differences between what we see kind of with the old, I say old school way of building applications, and then kind of the newer way where we use a lot of APIs within our systems, and why we do that, but also the complexities and the differences that brings in. So the first thing I wanted to do is, really just say, like, how are we getting here, and what's the problem that we see? And I don't know if anybody has seen recently. This just actually came out just the other day, maybe about a week or so ago, I guess. Millions of transactions scraped in latest demonstration of Venmo's absurd privacy policy. Now, I hear talk about their privacy policy or anything like that, but we're starting to see more stories like this where applications are really relying on these APIs. We've built up this functionality to do little teeny pieces of work, and we make calls to them, whether that's from our mobile, our web, wherever, to be able to pull data down. But this is a clear example of why we see some of the complexities that I make this functionality available, but now how can people abuse that functionality? How is it different than a full web page? So we're going to talk a little bit through what it used to look like, sort of, and what we're starting to look like. Don't hate my graphics. But really, what we used to do is when we would load an application, when I started doing development back around 2000 or so, we loaded the entire page all at once. There was no, call out a little bit for this, call out a little bit for that. It was, I had a URL and the address bar, I made a request, and the entire page loaded back down. And when I edited something, maybe I edited a profile or I did a search on that page, it would post the entire page back up, or it would post me over to another full page. It would do all the processing on the server, and then it would send that response back down to my browser for me to be able to view the data, interact even more. But it was very server-side heavy, and we didn't do nearly as much on the client side. So that is kind of changing, and now what we're seeing, and the great thing about APIs is that we don't really see it, right? It's all kind of hidden behind the scenes. But now we take that same type of page and we say, you know what? I'm not going to load all that information all at once. I'm going to have a specific endpoint that I have set up, and that endpoint is going to be just very limited functionality. So maybe I only want to pull down the blog roll of this page that's being on here. Maybe I have recent posts. All these different little pieces have their own API endpoint. So now when I load my page, I'm loading sort of that shell of a page, but there's really nothing to that default page that came down. It's just a container, really. And then I'm going to make all kinds of separate little requests out to the server, and that could be my server, that could be somebody else's server. I'm going to make all these different small little requests, and then they're going to send me back those little chunks of data to fill in the rest of my screen. So this is great because now I'm not pulling back, a 600 gig web page down. I think before it used to be we had to try to keep our pages under, 100 kilobytes or something like that. We're not like that anymore, right? Because we broke this down so many different ways. So now, instead of loading that whole page, I can sit there and do a search, and it just sends up a small request for the search, and it returns back just the search results. I don't have to return back all the posts that exist on this page that we see as an example, all the stuff on the left, the navigation menus. It's a much smaller bit of data coming back and forth. So this kind of helps us kind of speed things up. We can lazy load data into our pages if we want. So that's where we're going with what we're doing with an API, is that it's kind of this hidden, small, very specific request versus I want to do this and computate my entire page all at once and then send it all back down all at once to me. And the nice thing that we see when we talk about doing this format is we get more device compatibility, because now I'm not writing for a browser. When I'm writing my server piece, I'm not sitting there putting back out maybe specifically HTML and JavaScript and all this stuff for a page to work in a specific browser. Instead, what we're doing is we're creating specific endpoints. So I've got here some examples like update user, get user, delete user, very specific functionality, and it's going to return a set of formatted data. So in a lot of cases, we're returning JSON now, which is JavaScript object notation. So it looks a little different than XML formatted data, which is kind of where we came from. A lot less data in the XML and JSON side, because XML, right, is very, very bloaty. But it's a format that can be consumed by anything. So now I can create this functionality, and I can write my server-side code to update my user, get user information or our profiles. I can delete a user. I can write that once into an API, and then my browser can have a front end to be able to call that server-side data. My mobile client can call that server-side data. My tablet can call it. My watch can call it. Whatever I want to have call it, I can all call this same function. I don't have to write them 17 different times for every different type of device that I'm trying to go to. So that's really what we're trying to do when we're switching kind of to this API idea, is that I'm not writing for a single client. I want this to be consumable by multiple mediums that we're going to have going forward. Now, there are some things that we have to think about, though, with API security. Now, a lot of the security risks for API, honestly, are the same as what we've been dealing with, whether you write web applications, mobile applications, whatever it is, a lot of them are still the same. So things like insufficient authentication and authorization, those are still problems that we have with an API. Injection flaws, SQL injection, command injection, any type of injection that happens on the server side, LDAP injection, XML injection, all these things are still a potential issue when we're talking about APIs. And I can tell you, when I test applications, a lot of the more modern applications I test these days, they are driven heavily by APIs, and we still have those same type of issues. Now, you may not see as much things like cross-site scripting, because remember, that's a client-side attack, and it's very specific to a certain type of client. So cross-site scripting may not be as big of a concern when we think about APIs, although put an asterisk by that one, because there still could be potential for that if you're not returning things, with the proper headers. But that's less of a concern than what we think about with some of these other more traditional vulnerabilities that we have out there. So, big thing I find that really kind of separates out an API from our typical load the whole page all at once type of scenario is, we think that if it's not in the URL, that it must be invisible. And way back when I started programming, we didn't have jQuery, and we didn't have all these other ways, and AJAX to be able to send requests and response behind the scenes. We had to do it with iframes. It was ridiculous. Now we have all these different ways, but so you load the page and you see one URL up in the address bar in your browser, but then there could be 40, 50, 600 requests happening behind the scenes to go grab data, bring it back down, send data up to update it, and take that information, and it all happens inside that browser window or the mobile application. We saw a lot of things like single-page applications now that don't make a lot of requests in front of you. So you don't see these requests going back and forth. And that's where I think when we talk about APIs, that's where a lot of the issues start to kind of creep in, is because developers often think, and I'm a developer, we think, I can't see it, it's not a problem. I can't manipulate it. And that's unfortunately not true, just like it is with web and mobile. We can see all those requests going back and forth, and we can manipulate those. So we have to make sure that we take care of those so we're protecting our app. So things like missing authentication are one of the more common things I see outside of our typical injection and all those. Authentication is a big one. You'll see where you have an API call that doesn't actually require you to be authenticated. And again, I think that assumption happens that, well, nobody can see this request because the browser's making that request. The user's not consciously making a request to that. So for some reason, we kind of forget to put authentication checks on there to make sure that you are able to make the request to that resource. We also have insufficient authorization, which I'm going to go into a little bit more, and sensitive information leakage. Both of those, these are kind of the bigger things I see that stand out from an API standpoint versus what we typically think about within our web applications, or that we overlook when we switch to doing APIs. So from an authorization standpoint, again, just like authentication, we miss it altogether. We just assume that, hey, if you're calling it, you're good to go and you can grab whatever data you're asking for. And again, it's that hidden side, but that's not true, right? We have to be authorized to be able to request data from our systems, whether that's in the URL of the address bar or whether that's actually happening behind the scenes. But don't assume that, oh, because I've figured out the URL of my API, that I must now have access to it, right? So we have to make sure that we have that authorization there. Same thing with direct object reference, which is always a problem. I see this all the time. If you've ever been out there, if you're not sure what direct object reference is, it's basically the ability for me to directly change an ID in most cases. You usually see it in the URL. You know, I want to delete user ID equals 5. And I say, you know what, I want to delete user ID equals 6. That's direct object reference. And if I can do it, that means we've got an authorization issue because I shouldn't have access to that user. Well, we have the same thing with the APIs. Again, they're not in the address bar, but I can still manipulate that using something like a web proxy, be able to see that traffic, resend that traffic, and I can modify and then start saying, oh, I want to see user 67832. And if it comes back, now I'm be able to view data that I shouldn't be able to view. And then I can script that so that I can then just increment that number and just start pulling data down and, you know, basically scraping all the data out of the database because there was no authorization check. It was just a check to see if I was maybe logged in, but not who I am and what I'm allowed to actually access. When we talk about sensitive information leakage, this one to me is kind of a big one. And the reason why is, again, we can't see the data, the raw data, within the browser. Now, if I open up developer tools, I can see that data. But by default, I really can't see what's happening. I get to see how the developer has decided to use client-side script to take the raw data from the API response and then display what it wants to display to me. And I use this in my training scenarios when I train developers in QA on security topics is, you know, I show them exactly this, an API that's returning back way more information than we actually display on the screen. So you say, oh, well, the screen only displays the profile information of name, email address, and phone number. But if you actually look at the response to that get profile API request, you'll see that it has maybe, you know, the password field in there. Hopefully it's hashed, but hopefully it's not there at all. But yeah, I've seen password fields in there. I've seen way more information, IP addresses, last time they log in, how many account lockouts they've had. I mean, what we'll see is somebody just go and grab the entire user table row and just dump it all back and then say, okay, client, it's up to you to determine what you want to display, and nobody will know that the rest of this stuff came back. And that's not true. Like I said, using a proxy or even DevTools, I can see everything that comes back in that request. So, but we want to make it so we have the easiest API to use, I guess, if you will. So it's like, oh, I'll create a profile API and I'll just, you know, I'll dump all these back. And again, I'll leave it up to the client to pick what they want to see. And so sometimes it's a little less general. So we want to make sure that we know the type of fields that we're returning back to the client, so that way we're not returning too much information, you know, for each type of thing that's happening. Because that, I see a lot of information being released, especially when I'm doing assessments, through that type of misconfiguration to bring that down. The other thing that we run into is there's no UI natively for an API. That's the whole purpose of it, is I can pick any UI I want and program it to that API. So because there's no UI, sometimes it makes things like denial of service or scraping data, anything like that, actually much more difficult to try to prevent, because I can't do things like put those captchas on the screen. I don't know about anybody else. I'm not a fan of captchas, but I can't put a captcha on there to try to slow down automated scripts. And we could argue either way if that actually works or not. But I can't put user interface type of things to try to limit that. So now I got to implement some sort of rate limiting on the server side to try to help to make sure that I am stopping somebody from doing this. And if you go back to that first screen I threw up talking about Venmo, Venmo had this same type of incident a few years ago, and they actually did implement stuff to slow down and add rate limiting into their APIs. The problem is, according to the article that I read, is that, that rate limiting is still allowed enough stuff that over a long enough given time, somebody could still go through there and kind of scrape some information. So it does make it really tricky to be able to do that. But for me, those are kind of the top things that I commonly see outside of the normal, like OWASP top 10 for web, that are kind of highlighting for what we see within an API. So that kind of wraps up that piece, Dan. I'll pass it back over to you, and we can move on through the rest of the presentation.
Great, thank you very much. I was just really tweeting what you were saying, actually. Maybe because I can refer back to my tweets later on with some of these questions. But yeah, big thanks to James for kicking things off today. And yeah, really, really great sort of oversight there. A lot of which did make a lot of sense, especially what we're looking at right now about, you mentioned about UIs and sort of maybe a lack of standardization, which we are going to come back to. I'm going to come back to those points later on. So again, thanks to James. We're going to move on and introduce our second poll question. So let's stop the voting right there. Big thanks to all of you for voting. So yeah, the first poll question we asked was about how does API security rank in your list of security priorities. We'll come back to that in just one moment. We're going to launch the second one that you can see on your screen right now then. So who is responsible for API security in your organization? So you've got 5 options: security team, a development team, shared responsibility such as DevSecOps, nobody, or you don't know, maybe it's not something you either outsourced, or just to kind of refer back to the previous poll. I'm just going to do some of the results from that first poll actually, because no one actually said we already have a solution for API security. So from those of you who chose to vote, none of you actually have that sort of solution ready. So, but 40% of you actually said low priority. So maybe you're just gathering details for your own education, and maybe this is sort of part of the process. So we'll come back to the full results from that, and we'll run through that a bit later on. But yeah, please do vote in the vote the poll that's live now. And again, we'll look back to that in a moment. Well, after we've introduced our second speaker, who is Roey Eliyahu. Roey is CEO and co-founder of Salt Security. So Roey, I'm going to hand the slide deck over to you.
Thank you, Dan. I'm hopeful that everyone can hear me now.
Yeah, sounds good. Thanks.
Okay, excellent. Okay, so I think I want to see that I see my slide, actually see my picture, so let's see, move forward and can see that. Okay, excellent. So thank you very much, and it's a pleasure being here. So actually, before I start, let me tell you about how I introduced to the world of APIs and the security aspects of them. So I'm based in Palo Alto. Originally, I'm from Israel. And my security background came from serving. It started at serving at the elite cybersecurity units of the IDF, the Israeli army. So this is where I really gained my security expertise in the military grade, and where I really saw APIs, the evolution of APIs completely change, or how we develop, our traditional web apps, as James explained earlier, to what we have today, that is completely different in terms of technologies, in terms of architectures, and which opens a lot of a complete new set of attack vectors that are not being addressed by current solution. And as we saw that as a problem that's only going to grow over time, it's something that must be solved. It's a huge problem, and we can leverage the newer technologies of big data, AI, in order to solve this growing problem. So that's kind of what was the foundation of Salt. So let me start by talking about the API economy today. You can see that there is basically an API are rapidly increasing. You can see it everywhere, from financial organization to mobile companies, SaaS companies, healthcare, automotive, all across. Actually, you can see that every company, becoming a digital company, right? The other day, you go into your, even now, hotels, Airbnb, so instead of having like a manual lock, you'll start seeing companies like Yale producing now digital lock, right? So you can configure the lock from your app, you can open it. Now the car is being connected to your app, so you can unlock it, you can track it, You can start the engine from the app. So you can see everything becoming more digital, more smart cities and so on, autonomous vehicles. Everything is being connected through APIs. So the entire economy is now estimated about $2.2 trillion already in 2018. So you can see like the huge spike. Talk about how it was in the past, and I'll do it a bit quickly because actually James kind of iterates some of those messages and what's changed, and then I'll talk about more, give you some examples of vulnerabilities that are more current and talk about more what we do in order to solve those kind of problems. So this was the typical architecture for traditional web apps. As James said, right, we have the client sends a single request to the backend, render a complete HTML page with all the data in it for all different sections, return them back to the client to present the entire HTML page. And then you had the very common attack methods like remote file inclusions, cross-site scripting, SQL injection, and so on, which led to the development in the early 2000s of WASP solutions, and then later on of RASP to mitigate some of those risks. But today, the world is transitioning, to something that looks more like this. You have different clients, right, like mobile apps, web app, devices, all communicating using REST APIs. You have, the majority of them with a backend that built out of completely new technologies. We have new languages, new frameworks. Now with Docker and Kubernetes, companies are moving to microservices, so you have internal APIs as well. And if you look at the attack methods, you can see that a lot of them became non-relevant, nor prevalent as before because of two main reasons. The first one is the growing usage of ORM. So for the ones in the crowd that doesn't know, ORM basically is the library that interacts with the database, that help you to query the database in a very efficient way. So you don't need to assemble the queries manually like in the old days, and actually take the user input, put it as a one string and then send it to the database. So now the database, providers create the library for different languages to interact with it. The thing is that it contains built-in injection protection, so it's block most of the injections that just because it put input validation, strict typing. So it prevents actually a significant amount of the use cases for SQL injection and other type of injections. And the second reason that a lot of the technologies was used in the past became obsolete. So for example, you wouldn't see, single page application with PHP as an example. So every attack targeting PHP specifically became obsolete as well. So you can see a lot of those attacks and how we authenticate also eliminate a lot of the attack methods that were, the number one threat in the past. What was created is actually completely new attack methods that actually James also referred a little bit in his presentation about how you can bypass certain authorization of authentication controls, how we can potentially override users' information and maybe reset the password, broken authentication, improper data filtering, which means exactly like James referred, you send an API call, you get a full field, not only maybe a name or a basic information about the user, maybe you can get more info, like the entire row in the database, like, how many have been locked out and a lot of data. So it's not only for users, it's actually for any type of call. But if you look at all the attack methods that are now responsible for, you can see almost any breach, like we actually gather all the data. It was almost over 90% of the incidents and vulnerabilities we found in the last 2 years. Actually, over 90% of them, you can see it was using the more new attack methods that target more the logic of the API. And you can see that if you review case by case, you can see that those attack methods are not being addressed by current solutions. And just as a sample set, and there is many more, but different attacks, vulnerabilities that have been introduced, some of the top companies, obviously invest a lot in security. You can see that each of them, it was really the new attack method. Now, before giving you some example, I will say that the new attack methods are more targeting the logic of the API. So the number one that I mentioned here, the broken object level access control, it's really all the different ways how to manipulate an API in order to access some data that you are not supposed to access. So a good example that actually James gave is changing an ID from one ID to another in order to access somebody else's information. So instead of, let's say what happened in Venmo, instead of accessing my transaction data, I will enumerate the ID and we'll check for other transaction data of other people. And they didn't implement proper authorization for that. So you can see the same way happening in T-Mobile, in USPS, in YouTube even, it happened in Facebook. So you can see it in many cases. Actually, that's why it's top one. And I can tell you also that we were selected to lead the project for OWASP, for the API security project, the top 10 threats. And we are releasing the top 10 threats as of September this year. And you will see a big change between the old top 10 threats to the new one, that actually those threats became, top ones. And all of the injection was pushed to below the seventh or the eighth place in the list instead of one for APIs. So that being said, let me jump to show you an example. So how look like a common scenario for an API breach. So usually, and by the way, just to mention another case about Facebook, it's actually a great example. There was their developer bug basically that allows to exfiltrate or to get a secret token of another user, which is equivalent to a password. Once I have the secret token, I can do whatever I want with it. So you can simply enumerate, get access of different secret tokens. So the attackers got 50 million secret tokens and basically access all of the data. And now they're facing up to $1.6 billion in fines under GDPR. Now, you can see clearly it wasn't an injection attack. It was a subtle manipulation, enumerate ID, and then you can get a secret access token. So it's the same type of vulnerabilities going over again. And the reason why the current solution cannot address it, because it's not something you can signature. You need to know the APIs and the specific behavior of the API in order to understand if it's legitimate or not. Maybe, to return a secret access token, it's okay. The solution looking more for patterns of injections that obviously just a developer bug, it's not an injection. So a normal scenario that you have a business requirement, to add another functionality to the product. So let's take John, amazing developer in Acme, and he's being asked to add a user profile page to the web app that they're building. So John comes, develop the API logic to request a specific user data by a specific user ID, to return the specific user data, and to add a user profile page. Then an attacker will think about how can manipulate this logic in order to exfiltrate data. So based on a completely real example that we found in actually more than 2 customers, an attacker can come, omit the user ID completely, so just remove the key and the value. So instead of filtering one user, just pulling all the users out. Now, I want to emphasize this is not like putting the user the value. So this example was happening in a company. They had a NoSQL database. It was MongoDB, and they had all the checks in place. So they had a WAF for one of the biggest WAF in the market. They had an API gateway. They are doing vulnerability scanning and actually doing cold deep penetration testing. So they're really, really, security conscious. But still, it went under the radar, and none of the solution or processes were detected this vulnerability. And the reason is that you have hundreds of API calls. Every API call has, tens of hundreds of parameters. And in one API call, user ID was mandatory to appear. Not all the API calls, it's mandatory to send user ID. Sometimes the client just sends it, but there is no usage for that. The solution was granular enough to understand that specifically in get user profile, user ID must appear, because otherwise it can cause a full data dump of the database. And this is one example out of so many that you can see how you can manipulate the API by removing one field, changing the order of field, changing the values of the fields, maybe do actions in specific order, different order, in order to generate different results. So it's a lot of subtle tweaks, understanding the business logic in order to exfiltrate data most of the time, take over accounts, So a good example that we found, we're doing a lot of research with our customers, and we found in one of them that if you add a password field, like password equal 1 to 6 in the payload field, in a payload in one of the API calls, you can actually override the password of the user. So you can enumerate the user ID from 1 to 1 million. You can put a password field in one of the payload calls that normally does not appear in this call, but because they're using a specific feature of a framework in Ruby, so it's modified automatically the object in the database. So you can basically change the password for all of the users and then basically hack any account. That you have a single API call per account, so you don't even guess the password, just change it. So it's, again, very common vulnerability. We see that all the time, and cannot be detected because by current solution, because it's just you need to understand the API in so granular details to know that this specific field normally should not appear in a specific call. So with that, let me tell you about how we, in this example that I just showed you with John, how Salt would have detected those cases. So as soon as John pushed the new feature, so our discovery module that based on the API usage modeled the entire API environment. So we know all the APIs, all the API endpoints, all the parameters going through the endpoints, and tagging automatically all the PII. So as soon as the new feature is out or the new API is out, we will detect all of the the new APIs that change. So you have a complete visibility of what's happening in your API environment, in your production environment, all the time, and you are aware and you have a way to manage any change on new APIs. I can tell you in 100% of the time that we are going into a customer POC, we see or we discover a lot of APIs and data that they are not aware of at all. Legacy application, different application, new services, new endpoints of services that are not being properly documented. So many, they're always shocked about the things that we found. Very similar to the CASB space, they had the shadow IP. Here you can have like a shadow API. You can see that all the time. The second module that we have is the prevention module. So as soon as an attacker looking for vulnerability, so because what is the first step for an attacker to how he finds the vulnerability in an API? He starts doing a trial and error process. He's guessing where the developer, made a mistake. How can I manipulate the logic? How can I tweak the API call in a way to cause, exfiltration of data, or take over accounts, or disrupt the service? So as soon as an attacker starts to manipulating the API call, start to attack the API, our prevention module will detect in the very first attempt. So what we are doing, we are leveraging big data with continuous analysis of the entire API usage to determine what's the normal behavior. And then we detect all the abnormal activities correlated to specific users. So even if they are coming from different, thousands of different IPs, we can correlate to find a single user behind it using a user ID, user token, using a device ID, any type of identifier that you have in your API. And we assemble a full timeline and calculate the risk score based on the entire activity that this specific user was generating to determine if it's an actual attacker or not, or just, a user behaving abnormal. Because the user can maybe put, I don't know, like an email server name, that's abnormal activity, but it definitely is not something that you want to get alerted for. But the power of looking the full of all the activity in our attacker, it's the key to eliminate false positive. Because if you look at the solution that exists today, traditionally, they're looking at the request response and determine if it's good or bad, contains codes or not. As soon as you have even a tiny scanner that's being run, it's just generating thousands of alerts, and then and not talking about a lot of false positive as well. So it's creating basically a mess that's really hard to navigate, especially with APIs becoming such a high volumes, interfaces. So we took more what's been implemented in different markets, maybe network security, endpoint security, actually assembling a full timeline. So you have a story, understanding, that in a specific company, there is a specific attacker, try to attack different APIs. Here's all the activities. Based on all the activities, you can definitely determine this is an attacker looking for vulnerability. And then we connect back to your firewalls, your CDNs, your gateways, and so on to enforce automatic action. So we can block, we can suspend, we can report to any SIEM, and so on. So you can do any playbook that you want. And lastly, not only that we're blocking the attackers, we are also have remediation modules that leverage them as penetration testers. So we literally leverage the resources of black hat hackers as your own penetration testers. So as soon as they finding some vulnerable points after they've been blocked, we create JIRA tickets or any type of ticketing system to your developers about what are the vulnerable points and how you can fix them. So basically, based on the response from the server, the system can tell if there's a vulnerability being found. So let's say somebody sent a malicious input in one of the calls, and the server, and we know what's the legitimate input, and the server didn't reject it, returned 200 OK normal data. There is a clear indication that no validation was in place. So we will generate this ticket that that is very easy to understand for developer, usually being fixed in minutes because simple validation checks. And then you can continuously harden the API. So the more you're getting attacked, the more you're getting secured. And you can also focus on the vulnerabilities that actually matters because, if you want to try to fix everything, it's a lot of work. You have limited resources to focus on the one that are being probed continuously versus the one that's never been probed to help you to prioritize better your resources. I'll talk just about the team. So our entire team, we have an experience. We already successfully scale companies from zero to over $100 million in revenues in the cybersecurity space and different spaces. Most of the team is ex-elite cybersecurity and intelligence units of the IDF. So we live and breathe the cybersecurity field, all of them being in both offensive, defensive, cyber, so we know both sides. And we are really excited about the solution because we're really attacking this new problem that unfortunately is not being addressed today, and we continue to see every week a new breach. So with that, I will wrap up my presentation for Q&A, and hopefully it was interesting for you.
Awesome, Roy. Thank you very much for your presentation. I've been tweeting along with both Roy and with James today, mainly for my own reference, to be honest. So if you have been following the discussion, that hashtag Infosec webinar, then I'm just gonna push that slide back a little bit because I do notice. There we go. Just forward. I think, yeah, you click through there, just a bit more information about Roy and some of the board there of Salt Security. I think we whizzed through that before we went to that one. So yeah, big thanks to Roy for joining us today, and obviously for Salt Security for sponsoring today's webinar. So let's bring that second poll to an end. Big thanks to all of you who did that, and we're going to have quite an interesting findings from that. So I'll come back to in a moment. What's your top concern with regard to securing your APIs? That's been trying to read too quickly. Right. What's your top concern with regard to securing your APIs? You've got 5 options there. We'll run this. We've got just over 10 minutes left this webinar, so we'll run this for the sort of duration of the remainder as we kind of get into some of the points that have been made. Is it preventing account takeover, preventing data loss, preventing service disruption, eliminating vulnerabilities, or improving visibilities? I think we've kind of focused on certainly 2 of those today, actually. No, I suppose probably all of them, actually, but certainly 2 that stood out to me, which I'm going to get to in just a second, but I'll try not to influence the vote too much. But yeah, we're going to come back to that actually as we look to wrap the webinar up. So please do vote for that. If you have any questions in particular about sort of security and the way they're doing things, or if you want to talk a bit more generally about some of the points that have been raised, then don't miss the opportunity. Because, yeah, it might be a little bit basic, but we'll push on with those. Of what the first in your list of security priorities, 40% said low priority. I'm gathering details from my own education. Thanks very much for joining us for this. 25% top priority. We're actively evaluating solutions. 22% medium. We're gathering details about solutions. 11% high. We're starting to gather details and talk to vendors, and say 0 for API security. James, let's maybe just push that question to you first, and because it seems that 25% say it's very top priority, 40% say low priority. We don't have visibility of who's actually listening. Do you find that people are taking? I mean, the AppSec is obviously a big deal. I've just come off of Infosec about 3 weeks ago where I talked about vulnerabilities and patching for 3 days, it seemed. Is this still, is this part of people's strategy, you feel, that, API security, does it fit into the wider AppSec approach to working?
It does, but, it's a little bit different. Like I said, a lot of the tools, that we typically see for a lot of our regular applications, think about web application, some of the dynamic scanners that have a little bit more difficulty trying to go through and crawl an API, that doesn't did with a web application. So, it's there with everything else, but it does have its nuances, and that does make it a little bit more challenging. Now, if you still look at APIs, though, as far as from a development standpoint and a design standpoint, there's not a lot of difference there from the things that you're doing. Like when you're coding and you're designing, you're thinking about doing authentication, authorization, who has access to this, does the user have access to these records? That stuff is not changing. It's just that in the ways that some things can be attacked, and to be honest, really the ways that we can test it to verify that what we think we're doing is working, those are what are changing and make it a little bit more difficult. Because like I said, it's a little bit harder to sit there and just use, some sort of dynamic scanner off the shelf to scan your APIs, right? Because you still need to have a client side that they can automate to go through and identify where these are. It right now, for a lot of places, is a very kind of more manual process, or trying to put something together with something like Postman and, trying to automate that. So I think a lot of it, what they're doing is still kind of the same. It's when we start thinking about how do we test it and verify, and then, when it's running, how do we, alert on things and keep it secure once it's deployed. Yeah.
And it's a question actually that's been sort of kind of on my mind throughout the last sort of nearly 50 minutes. Is how do people actually? People I guess don't write all their own code these days. We know that people use code repositories and things like that. Is that where the API? Are people writing their own APIs? Is the question really? Is that something that they write their own APIs, or are they using external APIs? Where does the API come in?
It just depends on your use case. A lot of applications now, internally, people are writing their own APIs. Now, your code base still has a ton of third-party code, right, that you're going out and getting and using to perform functions. But imagine you're thinking about the API. If I'm just building, my own lawn care site, you can come in and order lawn care. I'll come cut your lawn, do all this stuff. If I'm building that, I still may build that using APIs because I want to write once and then be able to have a mobile app. I want to have the iOS app, the Android app. I want a web app. I want, an app that works on my watch if I want. So I'm going to use an API to break up my app so that way all these devices can all use the app, right? And I just wrote that server-side once versus, just writing it to say, hey, I wrote this for the web. And someone's like, hey, I'd like to connect my mobile to that. And they're like, yeah, you can't really do that. You have to scrape it all. It's a nightmare. But you also have the scenario where you have, I'm a third-party service provider, and I've got information I'm going to allow you to grab. So like Google APIs, there's all kinds of APIs out on Google, to be able to pull mapping information or pull this other information. So App A wants to be able to include data from App B, and App B has provided APIs for you to be able to gain access to that and pull it in. So it really just depends on the scenario they're writing. But a lot of the apps that you're seeing, they're most likely a lot of in-house APIs being written.
Got it. Yeah, that makes sense. I'll tell you a quick one before I move back to Roy, actually. I had an idea for a while, and please, if you're listening to this, anyone who wants to patent this and steal this, feel free to, where I go to events and people come to me and sort of say hi, and until I can see their name badge, I don't know who they are. And I had this idea of doing an API of LinkedIn into like Google Glass. and doing that, and sort of at that way, sort of bypass, and then up towards me comes James Jardine. I was like, oh, I know who James is already. But when I'm a black hat in 2 months or whatever it is, you walk up to me on RSA or whatever. Is that the kind of? I mean, this is a stupid idea, and actually, if anyone wants to steal this, then feel free to. But is that the kind of thing where, like you mentioned, Google Maps is a great example, probably better than mine. But is that one way of moving forward then, actually, where an API could be used, like that sort of an example?
Yeah, I mean, that's definitely a way that you could use it. I mean, if LinkedIn has APIs available that says, hey, look, if you authenticate, and, we see this all the time where it's like, here, you got to give permission, right, to Gmail or Google Drive, so that way something can do something with those services, right? There's APIs driving all that stuff, so I can have my app that says, you know what, I want to be able to pull my calendar information into this app out of Gmail. So I've authorized the app to be able to access my Gmail stuff, right? So it's going to use APIs behind the scenes to go up, query my calendar data, bring it down into this other app and be able to display it. So same thing what you're saying, right? You got your glasses, you got some app running on there, and you're like, look, I'm going to tie this into LinkedIn. I'm going to tie it to Facebook, tie it to Maps, and we'll be able to pull all this information in. So when you walk up, I can see where you've been for the past 50 minutes, so I can talk to you about the last booth you looked at.
Yeah, no, that makes sense, yeah. Oh, yeah, so if anyone who wants to take that, please do. But, up towards me walks, some CEO, and I'm going to remember, A, which company he works for, and B, where I met him 5 years ago. So that's typically the way it is. But just before, let's move back to Roy then, actually, and ask you about just that poll question then. Like I said, it was very mixed. It was 25% were top priority, 40% were low priority. Roy, in terms of the kind of the people that are coming to you at the moment, then like potential customers, existing customers, how many of them are actually doing API security as a kind of an outstanding part of their work, or is it something that people fit in amongst the other work they do?
Mm-hmm. Yeah, I think it's really depend on the sector. We see a lot of companies coming from the SaaS space, financial services. When the data is really, data exfiltration and account takeover is really like a high priority. And in those organizations, we see a lot of demand and top priority, especially due to different regulation like PSD2, open APIs, that obligates financial services to open their APIs to everyone. And SaaS services is basically the core of their offering, right? If they lose their data, they'll basically have a tremendous impact on their business. So we see for them like a top priority. The third vertical that we see is a lot of automotive companies are getting more digital, so their products now connect, like a car connected to the cloud or to an app, or, traditional company manufacturing, connecting the machines now through an API. So it's a new attack vector for them that they are never secured in the past. So they are looking for proper solutions. So I can tell you that we see a clear trend. In some verticals, it's more advanced, but in others, we see a clear trend. More and more companies are looking at API security, especially with every breach that, in the news every other week.
Yeah, and also I think both Roy and both of you and James both mentioned about vulnerability. I think James, going back over my tweets, was he said that traditional vulnerabilities exist in APIs. I think you said something very similar about attack methods as well. I mean, is that one of the problems here, Roy? Is that actually this is kind of a different way of working, but actually we're still facing the same old problems?
Mm-hmm. Yeah, I think it's, in a high level, when you think about it, both of them were, even if it's an injection or different vulnerability, it's still you exfiltrate data, you take over accounts, or you have different ways. For me, it's more the way you do that changed because of, the protocols change, the authorization methods change, how we communicate to the servers change, and basically the API became more rich in functionality. So if in the past we look at traditional apps, you have a few URLs, basic calls, and you don't have too much, maybe in the tens of calls, the best case. Today, I can tell you, just as a stat, we are going into a company, 1,000 people roughly. We see over thousands of API, hundreds of microservices. Every microservice has different calls. Every call has tens of different parameters. So the attack surface became significantly larger, and also the API is changing more often. So if you think about it, in the old days, you would release a version every 6 months, maybe. And then you have a pen test, and then you have all the, the processes in order to release the version is very secure. Today, everything become more agile. You have, CI/CD, continuous integration, continuous deployment. So you're deploying, we see companies even doing daily, the extreme, but, to do it every month or so, it's very common now. So you have not only that the attack surface is so big, it's also changing all the time. So the developer can change an app, can change functionality. So even if you test something, it's not valid anymore. So I think all those together, technology, the surface, and the fact that it's changing, all together ended up in a result that became API very vulnerable. And now they have more sensitive data because everything is going through an API. If you look in our apps, so it's a lucrative target for an attacker. So the combination created, a rising attack vector.
Yeah, it's a new vector, I suppose, isn't it, really? Nothing ever gets more secure. Let's just have a very quick whiz through the last two polls then. So actually, this quite interested me. And Roy, maybe we'll come back stick with you for this. Who is responsible for API security in your organization? 53% shared responsibility, like DevSecOps, rather than 16 each. Security and development, so sort of 32 if you put those two together. Only 6% each for nobody or I don't know. But we're seeing quite a lot of talk about DevSecOps and more sort of agile working, Roy. But actually, when it comes to API security, it does seem that's one way of it working. Did you see that quite often?
Yes, I'm sorry, Dan, I just missed the last two sentences. What I see quite often?
Sorry, I'm about to cough. I was going to say, are you seeing more, we see quite a lot of talk about agile working in DevSecOps now. Is this one way you see that agile working and DevSecOps is being utilized is for API security?
Mm-hmm. Yeah, definitely we see more in the technology company. We definitely see more the DevSecOps. We see like the complete cycle of mental security. They try to implement it as part of part of their continuous integration, how they can, write an API, document the API, going through some testing, release it to production, monitor it, and you have like everything. They try to automate everything with playbooks. So we see that really plays in technology companies. In other verticals, I think they are definitely looking to, wants to be in this place, but still not there. But they're walking their way there.
Yeah, sure. And we'll just wrap up that last poll as well. What is your top concern with regard to securing your APIs? Let's stop the voting there. Thanks to all of you for joining in today. 41% preventing data loss, 34% eliminating vulnerabilities, 17% preventing account takeover, 6% preventing service disruption, and nobody for improving visibility. James, let's just come back to you for the sort of the last point in on this. So 41% was about data loss. I think it was Roy who mentioned about password exposure, and I think we were chatting about this offline. And then 34% for eliminating vulnerabilities. It does seem, just like Roy was saying, it's kind of the same old problems that we're still trying to achieve with, even though this is maybe a slightly newer way of working.
Yeah, quite honestly, whether you're looking at API, whether you're looking at the old full page request, the goal is still the same, right? It's still protecting the organization, still protecting the customer, and a lot of these, really kind of fall into the same category. When you talk about limiting vulnerabilities, you're still really talking about preventing data loss. Same thing with account takeover. Somebody takes over your account, a lot of times that's leading to data loss. So all these things are really top priority. I think a lot of times it's just think about how you think about it. And I think one of the reasons we see data loss kind of picking top of the head here is just because of all the things we see, like GDPR. We see so many data privacy regulations coming out that it is kind of that top of the mind concern, so it's easy to grab that. But I think, really, if you were to talk to anybody, you want to make sure, your accounts are obviously not being able to be taken over. Again, it comes down to making sure that you're protecting your customers, protecting your organization, and making sure that everything has as little risk as possible that can be there.
Great. I think that's a really great point to bring things to a close on. So again, big thanks today for all of you for listening. Our speakers today, James Jardine and Roey Eliyahu, and of course our sponsor, Salt Security. Of course, also more webinars actually coming later this week. We'll be back on Thursday with 2 webinars, in fact, actually. So do look on the website for those, www.infosecurity-magazine.com. Also, you can listen to that. This webinar will be available very soon. Listen all over again, so you can start all over and sort of see my process of knowledge as I've learned about APIs over the last 60 minutes. So big thanks again to our sponsor, Salt Security. Also, if you can rate the webinar on the way out, you'll give an option to give it a star rating, and please do let us know what you think, and also let us know any questions of anything that you kind of would like to hear talk about in the future. Obviously, always tweet us, email us, let us know things you'd like us to talk about. 25th, I get the date, so do look out for that.